Well, we made it, everybody. Welcome to the final Key Stage 4 science lesson of this year. And the title of today's lesson is Electronic Structure. And we're still looking at atoms again. And this time, by the end of the lesson, I'd like you to be able to describe how electrons are arranged in the shells of atoms. And I'd then like you to take that a step further and represent those electrons in diagrams. The lesson with some retrieval, and today what I'd like you to do is pause the video now and answer the two questions on the screen. Hope it wasn't too difficult for you, particularly the first question. So if an atom has a mass of 31 and an atomic number of 15, and it's asking you to describe the structure of that atom, so it's wanting you to talk about protons, electrons and neutrons. So it would have 15 protons and 15 electrons, because that number is determined by the atomic number. And the number of neutrons will be the mass minus the atomic number. So 31 minus 15 is 16. Now isotopes are a little bit more difficult to get your head around. You've got two atoms, you've got carbon 12 and carbon 14. They're both carbon atoms, but they're slightly different from one another, and therefore they're an isotope of each other. So each isotope would have the same number of protons and electrons because it has the same atomic number, but it would have a different number of neutrons because it has a slightly different atomic mass. Attention now to electrons. I'm not interested in protons, not interested in neutrons in this lesson, just electrons. Okay. Now electrons, where you would find them in an atom is you would find them on the shells. So the first shell has space for 2 electrons. So 2 electrons can sit on that shell. The next shell, the second shell, can hold up to 8 electrons. And the third shell can also hold up to 8 electrons. The final shell, the outer shell, although it's the biggest, as far as we're concerned at GCSE, it can also only contain 2 electrons. And the rule is this: you must fill the shells from inside to out. So let's have a look at what I mean by that. If I was to tell you that carbon has 6 electrons, how would they be arranged on those shells? Well, you can't put 1 on the first shell and 1 on the second shell, and then I think I'll have 3 on the third shell and 1 on the final shell. They follow a pattern. You have to work from in to out. So they would be arranged in that order. There would be 2 on the first shell. Now, if I take 2 from 6, that means I'm left with 4. That means all 4 have to go on the second shell. So what about that one? What about magnesium? It has 12 electrons. How would you arrange those? Well, you'd have to do it this way. You'd have to put 2 on the first shell. That leaves me with 10. That means I can put 8 on the second shell, and that leaves me with another 2. And so that 2 final electrons can go on the third shell. So they would be arranged in the order 2, then 8, then 2. And finally, what about potassium? Potassium has a whopping 19 electrons. How would you arrange those? Well, starting from inside out, you would put 2 on the first shell. That means you've got 17 left. That means you can put the whole 8 in the second shell. So that means I've used 10, which means I've got 9 left. Well, I can put 8 on the third shell, and I'm left with 1 electron to go on that outer shell. So they would be arranged in the order 2, then 8, then 8, then 1. Let's go back to our example then of carbon. And we know that carbon has 6 electrons, and we know that they will therefore be arranged 2 in the first shell and 4 in the second shell. So I've drawn out the first 2 shells. I only need those 2 shells. Carbon doesn't have those empty shells around it waiting for electrons. It has 2 in the first shell and 4 in the second. So the way that I could represent it as a diagram is I'm going to use a cross to represent the electron. So I'm going to put the first one there and the second one there. Now you can put them wherever you want. You can put them side by side, across the way from one another, one at 12 o'clock, one at quarter past. It doesn't matter where you put them, but 2 on that shell. Now that shell's full, so the next 4 have to go on the second shell. And just for neatness sake, I do like to draw them like that, but you can put them wherever you want. And I would finish that diagram by actually putting the arrangement underneath. So anybody who sees that, any science teacher that sees that knows that that is an atom of carbon, because the electrons were arranged 2 in the first shell and 4 in the second shell. Before I set you the work to do at home, let's have a go one together. and make sure that we can do this before we move on. So phosphorus is an atom that has 15 electrons. So they would be arranged 2 in the first shell, 8 in the second shell, and then 5 in the final shell. Okay, so I've drawn the 3 shells for you. Could you have a go at drawing that atom? Okay, so 2 in the first shell, 8 in the second shell, okay, so now it's full. 2, then 8, and the next 5 would have to go on the outer shell, like so. 2, then 8, then 5. So, and that I would like you to email your teacher is this. I'd like you first to copy and complete the table that's on the screen. So the first one is done for you. So it's the atom is fluorine F, the mass is 19 and the atomic number is 9. That means it has 9 protons, 9 electrons and 10 neutrons, and the electrons would be arranged 2, then 7. So I'd like you to do that for the rest of the table. And the final thing I'd like you to do is each of those atoms, there are 5 of them, once you've got the electronic arrangement, could you then draw them out fully? Thank you for taking part in all the videos that we've done in the last 3 months. I hope you found them useful. Take care, everybody. Have a brilliant summer.